Hello, Algebra 2. Here's your agenda for Tuesday, October 6th. We're going to be doing notes number 18 and homework number 19. It's on the last slide, your homework. So there's two things we're going to do today, special cases and inequality word problems. So the essential question is, how do you write an absolute value inequality from a word problem? And so remember, there's two things that I'm going to do today. Please take out a piece of paper, title it Notes Number 18, and follow along. Okay, so I don't want you to write right now. I just want you to look at this. So there are special cases in absolute value. So I just want to draw your attention right here, what I'm highlighting in yellow. If you just watch for a minute, this is really easy. I know there's a lot of numbers on here, but just pay attention for a minute. So if you look here, it shows an absolute value with being worth a negative number. So that's not allowed. Here it is, nice and short and simple. If your original problem that's given to you has this negative number on the right side, then your problem cannot be completed. So it's two special cases. 99% of the time, the answer is no solution. That's what you'll see. Every now and then you'll get all real numbers, but you don't have to worry about that because we really don't come across that too much. So this example right here is just trying to show you that if you chose a number 3 and put it right here and said it was worth less than -5, that could never be true. 3 is less than -5. That's not true. So all you need to take away from this is, if your beginning problem at the very beginning, if this is a negative number, then there's an issue. It's a special case, and your answer would be no solution. Okay. So here's an example of that. So I wrote up here that this is just listening time. You're not writing right now because this is just a very easy comment. So here's absolute values that are all set up. Absolute value with a negative at the beginning. Absolute value with this -5 at the beginning. Absolute value equal to a negative number. So what happens if an absolute value problem is set up with a starting negative number? Then the answer cannot be found. You answer no solution or all real numbers. So we always just go with the no solution one because very often in life you don't get the all real numbers. So all you need to know is you can't have, remember, absolute value. This represents that distance from a number line. It can never be set up to be a negative distance. That's another way to remember that those absolute value bars represent a distance, and there's no way that a distance could be starting out at a negative number. Okay, and your answer then would be no solution. Okay, so now if you get out a piece of paper, we're going to start notes number 18 for word problems. So I have two examples here. This is how you're going to write the absolute value inequality problem. So one way to think of it is there's always an X, always a minus, your perfect outcome, and the allowed deviation. Another way to do it or think about it, and you would want to write both of these on your paper. This blue is always a minus. It always has an X there. The number that goes inside the absolute value in red right here is your desired amount. You'll have one of these four symbols: less than or equal to, greater than or equal to. And then the number on the outside is a range, or you can call it an allowable deviation. Okay, so I hope that you have that written down on your notes. You can hit pause so that you can do that. Okay, so I just want to remind you about the types of graphs that we do have. With your less symbol, you're supposed to remember and, less and. So that gives you a range, and so your graph always comes out like this. So it's a range. With the greater symbol, you know what, I'm going to change that real quick. just because you can't really see it very well. Let's do this one. So it's always a range because it's the and, right? And that always happens with these two symbols. When you have the great or great symbol, greater than, great or, then your graph always looks like this. And you'll need that for the word problems. So a range is something in between this and that. The greater symbol or the great, and then gives you the or graph. That's what the great symbol gives, either or. So just bigger or smaller than this or that. Bigger than this or smaller than that. And then hit pause so you can write your notes down. Okay, if you can take a minute to write this problem down. Hit pause, please. Okay, you should be back. So the normal human body temperature is 98 degrees, 98.6 degrees. A temperature that differs from normal by at least, keyword is at least, 2 degrees, is considered unhealthy. So we need to first write an inequality. So we're going to draw the absolute value bars. So whatever goes in here has to be at least 2 degrees. Can it be more than 2 degrees? At least 2. So this has to be greater than 2 degrees. Okay? So when we put our 2 there, right there. And then all you have to do is put your x, your minus, and then the perfect number. Well, what was the perfect number? 98.6 degrees. Okay? So there you go. We set it up. Now you're going to solve it. So we're going to write it twice. And we're going to write it again, but this time flip symbol, change to -2, and then you go ahead and solve. So we want to determine what temperatures are unhealthy. If the normal temperature for a human is 98.6. So then we're just going to add 98.6 on both sides. So this one would be anything greater than, what is it, 100.66? 100.6. And again over here, add 98.6. This would be temperatures less than 98.6 minus 2 degrees would be 96.6. And if you graphed that, all the numbers greater than 100.6 would be this way. And all the numbers, oops, less than 96.6. Those are all the unhealthy temperatures, because a healthy temperature was 98.6. Unhealthy is greater than 100.6. Unhealthy is less than 96.6. Okay? All right, you can always hit pause to get caught up. Here's example number 2. If you can hit pause and copy this down. Okay, so you're preheating an oven to 350 degrees. The measured temperature has an absolute deviation, or it changes at most by 2 degrees. So remember, we want to set this up for absolute value. This is always an X. This is always a minus. So that can change at most. So it has to stay at most. So it'd be the less than symbol, 2 degrees. And where did we start? The preferred temperature is 350. And we should really have the extra line down here, right? Okay, because it can be exactly by 2 degrees. That's why we put the extra line down there. So we're going to go ahead and solve that. Going to write it once with the positive, and we're going to write it again. Flip symbol, change to negative, and then solve. Add 350 degrees to both sides. This temperature would be 352. Add 350 on the other side. This temperature would be, whoops, this temperature would be 350 minus 2 is 348 degrees. What are the acceptable temperatures for an oven to change by at most 2 degrees? So this is 352 degrees. Temperature can be less than that. The other one is 348 degrees. Temperature can be greater than that. So this is the range of temperatures that the oven can deviate or change by from 350 degrees, right? Okay, your homework ones are just like this problem. You're going to be using the less than or equal to symbol. So here's your homework. There's 2 problems. Number 1, number 2. Copy the problem, write the absolute value, and solve. Okay? So this will be homework number 19. You can hit pause so that you can copy that. Thank you.